Hey guys, welcome to lesson 621, day 2. We are going to continue talking about solving exponential equations using the power rule, but also we will be solving log equations as well, and they will be a little bit more involved than the ones that we talked about yesterday. So let's start by going over just, converting things between log and exponential form. We have to make sure that we're pretty solid with that in order to successfully solve these equations. So going from log to exponential is just the basic circle of life process. So from base to the other side of the equal sign, that's 2 to the 4th, and then from there back to the parentheses, that's t plus 7 in there. No matter what's in those parentheses, that goes in this position. Okay, it's okay that there's more than one term in there. It's not something that should throw you off. Right, same idea here. Circle of life, we've been doing this for a while, and people have been doing pretty well. Last one. Sometimes on my open math, you might have to use parentheses when you try to type in multiple terms like this. Just keep that in mind. All right, so that was a little refresher of going from log to exponential form. Now we're going to go backwards and go to log form. So just remember that we have our conversions here. Log base b of sum a equals x would turn into b to the x equals a. So this should help you go between the two. So here, remember that the base of your exponential is also the base of your log. So 3 is your base. And then in your parentheses will be the 7, because it's on the outside. A is in these spots, and then the exponent is always the answer. All right, and that's it. For this one, same idea. Base is the base. Exponent is the answer, so my exponent is 2, and that means I'm left with a 16 for my parentheses. All right, so now we can go ahead and talk about solving these equations. We're going to go through these, and we're also going to come up with a list of steps in order to help us. So there's a couple reasons why these are a little different than the equations we were working with yesterday. In this problem, hopefully you would notice that instead of just having an x in the exponent, there's a 3x now, so that's going to take a little bit more work for solving. And then here, there's an x minus 3 in the exponent, but there's also another minus 2 hanging out on the outside as well. So all of that stuff we're going to need to take care of as we're trying to solve these equations. So for this first one, remember our process from yesterday, right? The first thing we did was we took the log of both sides, and we did this so that we could use the power rule. All right, so we took the log of both sides, and then next we use the power rule to, shove that exponent to the back seat. So we end up with 3x log of 4. That 3x is gone now, so we just end up with the 4. Nothing changes about the log of 7. All right, next we have to realize that there's a couple of things going on here on the left side. Yesterday, we talked about how we would have just divided both sides by the log of 4. That was all we needed to get x by itself. But in this case, there's also a pesky 3 hanging out here. Now, it's not actually that problematic because really it is just being multiplied. Everything here is just being multiplied, right? Technically, there's a dot there as well. So in order to get x by itself, we can go ahead and just divide by everything we want to move. We want to move the 3, and we also want to move the log of 4. We are allowed to do this because they're all being multiplied. That's the only reason we can do this. Dividing by the 3 and the log of 4 cancels the 3, and it also cancels the log of 4. So that leaves us with x equaling log of 7 over 3 times the log of 4. So this would be what you would call an exact answer because there's no rounded decimals in it. But of course, you can also get your calculator for when I ask you for decimal approximations. and you would type that in as you see it. So we would have log of 7 divided by, now here's the thing, I need to use parentheses right here to show that all of this is on the bottom. Otherwise, it will do it in the wrong order. So please take note of how I put that 3 and log of 4 all in its own set of parentheses so that my calculator knows that it's all together in the denominator. All right, so I get an answer of 0.4679-ish. All right. So now in this next problem, we have a little bit extra going on, and this is where we have a new step involved. At the end of the day, we know that our first step has been, for a while now, to log both sides, right? But there's an issue with logging both sides here. Doing that is going to cause problems with this -2. Because so far we've only been used to logging both sides when the exponential term is by itself. So we need to manipulate this equation to make it how we're used to having it. We need to get this exponential term by itself. Okay, and that's, I'm going to go ahead and start writing my set of steps now for you. Okay, this is something you might want to write down. The very first thing we must do when we're solving these equations is to get the exponential term alone on one side of the equal sign. All right. So what I mean by that is we need to move this -2 to the other side so that this highlighted piece can be by itself. Now, you probably will be able to tell that we should add 2 to both sides in order to do this. That'll cancel the 2 on the left, and it would leave us with the 2 to the x minus 3 on the left alone, just like we wanted. All right, then we would go ahead and log both sides, and that's us using the power rule. Well, actually, we would log both sides and then we would use the power rule. So log both sides. So here, that would look like this. Gosh, I do that every time. I tell you to log both sides and then I don't. All right. So now we've done that, and at this point we can use the power rule to bring that exponent out of the exponent so that we can work with it better. So let's add that as our step 3. We'll use the power rule to bring the exponent down. All right, so this becomes, and maybe I should move this a little bit. All right. So once we use that power property, it looks like this. That whole x minus 3 is going to be there. It's its own entity, and that whole thing is being multiplied by my log of 2 now. Remember, it's just 2 now because x plus 3 moved to the back. All right, that is our step 3. So now, step 4, the thing about step 4 is that it is to solve for x. Now, I can't give you explicit do this, do that steps for solving for x because it's going to look different in every scenario. Here, it's going to be a little bit interesting. But at the end of the day, you have to depend on your own solving abilities for this step 4 here to go well. Okay, and again, I would really have these written down somewhere. I want to get, oh, that's really ugly, I can't. Get x alone. Okay, so for us, that means that we're going to need to do a couple of things. First of all, that x is trapped in those parentheses, which makes it a little bit difficult to isolate. However, we can move this log first, right? We need to move the log in order to even tap into those parentheses. So let's go ahead and divide both sides by the log of 2. And we end up with x, well, we can get rid of the parentheses now because there's nobody else there that we need to keep our distance from. All right, and now it's actually pretty simple from here. We just need to do one more thing to get x totally alone, and that means we need to move this 3 away. Okay, so that tells us that, I should have moved this down even further, x is going to be equal to log of 11 over log of 2 plus 3. This is our exact answer. Or if we want the decimal approximation, we can type this in. I'm going to pause recording while I do that so I don't waste my recording time. All right, I end up with an answer of 6.459. So squeeze that in here, and I'm done. All right, so those were how we solve exponential equations. Now, log equations are very similar in process or like in steps, so we're going to go through these kind of together. Okay, so the first step for solving log equations is similar to the first step of exponential equations, which is to get the log alone. All right, so here the log needs to be alone because right now it has a 3 stuck next to it, and here it has a couple of things stuck next to it. So we can go ahead and divide both, oops, that was reckless. Divide both sides by 3 to get the log alone. And here we need to do a couple things. First, we have to move away this 3. We always have to take care of addition, subtraction before multiplication. This p, I don't know how that got there. That's a typo. 2 log of x equals 4. And now we need to still get it alone. Oh, I forgot the base 5. Let's go ahead and divide both sides by 2 to cancel that 2 and move it away. Jeez. All right, so now we got our log alone on the left side of the equal sign here, and we did it here. Now the next step is really the easiest part, which is to switch to exponential form. All we need to do is do the circle of life and we will be done. So here we do this. We get 4 squared equals x. Here we do that same thing and we get 5 squared equals x. So we are pretty much done now. This tells us that x equals 16 because 4 squared is 16. And this tells us that x equals 25 because 5 squared is 25. All right, that is all for today.